Hi, I'd just like to show you briefly a program which I've been working on tonight, which uses the experimental OSC commands in Sonic Pi 2.12 beta. You've actually got to use quite a late version of this because the command's just been changed, and in fact Sam Aaron is at pains to emphasize that this command is entirely experimental at the moment. So although this is working at the moment, it may not work in a week or so because things may change. But it shows you some things that may be coming for Sonic Pi. Basically what I've got here is a standard piece of Bach, which has got two parts in it. The first part is stored in two arrays, A1 and B1. A1 storing the notes and B1 storing the durations of those notes. And each part is normally played in a thread. Here's the first part, which is going around and playing the notes in the A list and the durations in the B list, and there is another thread underneath which would normally play the second part. But if you look carefully here, you'll see that the play command, which was there for the first thread, has actually been replaced by the command OSC and then inside speech marks / wait for it, which is going to be the name of a sync which is going to be activated in the receiving program in a moment. Now it's not going to send the actual details of the play command, the sustain and release. Instead what it's going to do is to send three parameters. The note parameter, which is actually going to convert to a string, and then the duration parameter, which is in the B list, and then finally the tempo, which is in the C list just up above here. You can see use BPM C2I. So those are going to be sent, and the way that they are sent is they're not sent directly because unfortunately at the present there's a limitation whereby you can only work on the local machine for OSC commands sent by Sonic Pi. This is purely for security purposes at the moment, so you don't get arbitrary stuff coming into your machine and mangling it, but there's a way around it. What I'm going to do is to set up a path to send OSC commands from to the localhost machine, that's the one this is running on, and to port 8000. And if we move over to the right side here, you can see that I've got another script which is running in the language processing. You can see there that the script, or the sketch as they're called, is called OSC send, and it's running in processing version 3.22. And basically what this is going to do is it's set to receive any OSC messages which are coming into this machine on port 8000, which is where we're going to send them from over here. And all it's going to do is to rebroadcast these, because there's no limitation on this library we're using here as to where we can send these. It's going to send them to a machine on address 192.168.133 to the same port. And so what it does is that there's an event here when it receives a message. All it's going to do, it's going to actually print it on the screen so that we can see what it is or what the arguments are, the parameters sent with the OSC message, and then it's going to send it to my broadcast location, which is set up here, the second machine. Now the first machine is my iMac up here, the second one is my MacBook down here, and that's also running the same version of Sonic Pi, and it's also running a processing script. And this processing script is almost identical to the first one, except for the addresses. This one is going to receive anything which is coming in on this machine at port 8000, which is where we were sending them to from here. So it's going to receive from the first machine the OSC message, and then it is going to rebroadcast it. It's going to actually print out the message arguments so we can see them on this machine, and then it's going to rebroadcast them to the location 127.0.0.1, that's the local host, port 4559. And that's the port on which Sonic Pi listens to incoming sync information. So if we move over to the program which is running on this one, And you can see it's an expendable program to receive and play notes from Sonic Pi running on a different machine using parameters attached to an OSC sync command. And here we simply are going to have a live loop, which I've called receive. It's going to wait for a sync, which is called /wait for it, which is going to be sent from the first machine. And because we're saying s equals sync and then the name of that sync, we can get the parameters which are sent with this. And there are going to be 3 parameters sent. The first one, remember up here, was going to be the value of the note down here in the second part of the thread here. Let's just move that up a little bit so we can see it more. Move that up a little. There we are. The first parameter is going to be the note value. The second parameter is going to be the duration value. And the third parameter is going to be the current tempo. So if we move back down to this program, we can see that first of all we extract they're numbered from 0, these parameters. So S2 is the third parameter, which is going to give the BPM value, which you can see extracted there. And then we're going to check whether the note length is bigger than 3. If it is, it means that we've got 2 notes or more in a little list, and we have to deal with that slightly differently. But normally it'll just be 1, length up to 3, a colon C4, for example, or rather C4 or C#4. If it's more than that, then it'll go to the other mechanism. But if not, we first of all check to see whether the note is a rest. If it is, we don't want to play it. If it is, we're going to play it with, there's the note value. We're going to play it with the duration value, 90% of that, and release it with 10% of that value. We don't need to put in a wait because all that is dealt with by the sync for the next note. So we simply have to go back again and wait for the next note to come. So what I'm going to do now is to start this playing. Well, first of all, start this one here at the bottom playing. There we are. I'm going to click on that and start it playing. And that's now waiting for information to arrive. If we move up to the top one and we start it playing, and you'll notice if we go first of all just to the processing thing, they both got green arrows there. They're both running. I'll stop that one and start it again so you can see that. That's running. It's initializing there. There it's set up. This one down here is also running. And so now we move up to run this. And you can hear we've got both left and right hand parts playing. And to prove that it works, I'm going to come up here to the top machine and I'm going to select the volume and I'm going to fade it out. And all we can do is to hear the second part playing in the second machine. We'll fade that in again. And we'll fade out this one in the same way. If I change the cursor to here, fade that out. Oops. Now we've just got the first part playing. Fade it in again. So there we have each part being played perfectly together, one on each of the 2 machines. Hope you've enjoyed the video. We'll just stop it playing. Stop this one. They both stop immediately. Just see it starting off again, together. And you can see down here the note information which has been transmitted there by the first processing script. The same information down here, and you can see actually the notes that it's playing. I've got them to print out as they're received there too. So, thank you very much for watching.